Welcome to the channel. In this video we are going to discuss matrices, page number 91, example 3. Show that 1 determinant of 1 a square a cube, 1 b square b cube, 1 c square c cube is equal to a minus b into b minus c into c minus a into ab plus bc plus ca. So now in the solution, taking LHS, the LHS is given here. So determinant of 1 a square a cube, 1 b square b cube, 1 c square c cube. So in this, if you observe that, so here we have in the first column, all the elements are equal to 1. Now apply the row operations here. Now what I am doing is here, R1 to R1 minus R2. So R1 to R1 minus R2. That means this is R1, this is R2, this is R3. Horizontal lines are called rows. So now 1 minus 1 and a square minus b square. Here a cube minus b cube. And here further what I am doing is R2, writing in the place of R2. So that is R2 minus R3. Now what happens here? 1 minus 1. So this is b square minus c square, and here b cube minus c cube. So here the third row is writing as it is. So now here if you observe, so 1 minus 1 is 0, okay. Here a square minus b square is equal to. So a square minus b square is equal to, we have the formula a minus b into a plus b. A minus b into a plus b. And a cube minus b cube here, a cube minus b cube is equal to, we can write it as a minus b into a square plus ab plus b square. A square plus ab plus b square. So that's why here, so wherever, so a square minus b square is there, this is 0, 1 minus 1. Here a square minus b square is writing as a minus b into a plus b, and here a cube minus b cube is writing as a minus b into a square plus ab plus b square plus ab plus b square. Similarly 1 minus 1 is 0, and here b square minus c square is b minus c into b plus c, and here b cube minus c cube is, we can write as b minus c into b square plus bc plus c square plus c square, and last column row is as it is writing here. If you observe here, in the first row, in all the elements we have a minus b is common. In the second row, in all the elements, 3 elements, b minus c is common. Now here, taking a minus b and b minus c common, taking a minus b and b minus c common from R1 and R2, from R1 and R2, taking a minus b and b minus c common. So then we get here, in the first row if you take a minus b common, so we have here 0, and here a plus b, and here a square plus ab plus b square, a square plus ab plus b square. And in the second row if you take b minus c common, we get here, so 0, and here b plus c, so this is b square plus bc plus c square, and last row writing as it is 1 c square and c cube, writing as it is, this is. Now again what I am doing is here, applying the row operation, so R1 to R1 minus R2. So now which is equal to a minus b into b minus c, writing as it is. So here R1 in the place of R1 writing, so that is R1 minus R2, that means 0 minus 0, and here a plus b minus of b plus c, and here a square plus ab plus b square, and minus b square, so minus bc and minus c square. This is writing as it is. And here second row writing as it is 0 b plus c, b square plus bc plus c square writing. And third row is also writing as it is 1 c square c cube. Now further here, which is equal to, so here a minus b into b minus c into b minus c. So this is 0 minus 0, 0. And here plus b minus b gets cancelled, we get a minus c. And here plus b square minus b square gets cancelled. So a square minus c square, a square and minus the c square taking. And here plus ab and minus bc writing. Plus ab minus bc. And 0, here b plus c. So this b square plus bc plus c square. And 1 c square c cube. So these two rows are writing as it is. So here we have a minus b into b minus c into determinant of 0, a minus c, a square minus c square plus ab minus bc. And second row as it is 0 b plus c, b square plus bc plus c square, 1 c square c cube we have as it is. So now here what I am doing is a minus b into b minus c into determinant of, this is 0 and a minus c writing as it is. Here these two can be written as a square minus b square form. This is a minus c into a plus c, and here plus, here taking b common from these two, then we get b into a minus c. So here 0, this is b plus c, and b square plus bc plus c square, and here 1 c square c cube writing as it is these two rows, row 2 and row 3. Then here now further, which is equal to a minus b into b minus c. So here 0, so a minus c, and here from these two terms if you take the a minus c common, so a minus c into, we get here a plus c and here b into 1. So clearly we can write a minus c into a plus b plus c. Here a plus c and b into 1 if you take the a minus c common. So here 0, b plus c and b square plus bc plus c square, and 1 c square c cube is writing as it is. Now what happens if you observe in the first row, again a minus c is common. So taking a minus c common, taking a minus c common, taking a minus c common from R1, then what we get here? A minus b into b minus c, already we have, into a minus c when you take common here, a minus c, so into determinant of it, we have 0, 1, here a plus b plus c, here a plus b plus c, and here 0, b plus c, and here b square plus bc plus c square, and 1 c square c cube. This is writing as it is. See, if you expand the determinant here, expand the determinant along the first column. If you expand the determinant, so last element is 1 into, we get 1 present in the column, row if you delete, we get 1 a plus b plus c and b plus c, here b square plus bc plus c square. Now when you find the determinant of this is, we get a minus b into b minus c into a minus c, and here we get the determinant of, that is if you expand, so this is b square plus bc plus c square, and minus, so b plus c into, so we get a plus b plus c here when you expand the determinant. Then finally what we get here, which is equal to a minus b into b minus c into, here a minus c, and when you multiply this is, so here b square plus bc plus c square as it is, and here when you multiply with minus b, this is minus ab, and minus b square, and here minus bc, and here minus c. If you multiply these all three terms, minus ac and minus bc, and here minus c square, minus c square. See, observe here, plus c square minus c square, and plus b square minus b square. So plus bc and 1 minus bc gets cancelled. Finally, we have here a minus b into b minus c into a minus c. So here minus ab minus bc minus ca here. So minus of ab plus bc plus ca, if you take the minus common, then if you multiply with minus a here and plus c, if you multiply with minus, this a minus b becomes c minus a. When you multiply this a minus c with minus, we get c minus a. So that's why finally we can write this is a minus b into b minus c into here you get c minus a. So into ab plus bc plus ca. So this is the RHS only we require to prove. So like this we can prove, therefore LHS is equal to RHS.